Hi everyone, I'm Sanjeev Kumar from IT Bombay. Today I will present our work SrcMix, mixing of related source languages for extremely low resource machine translation. This work is about a simple but important questions. Like, can multilingual training actually help extremely low resource languages? Let me first define the problem. Extremely low resource languages or ELRLs typically have less than 10,000 parallel sentences, and in these settings zero sort transfer performs very poorly, and surprisingly the naive multilingual training often makes things worse. So instead of helping, multilinguality can introduce negative transfers, and this matters because millions of speakers remain digitally excluded. So the standard approach is many to many or one to many, but this creates two major issues. First one is the negative interference, and second one is decoder confusion. So our key hypothesis is that the main bottleneck is decoder and instability, because the decoder is forced to model multiple target languages and language distribution simultaneously. So we ask, what if we stabilize the decoder? Our idea is very simple. Instead of mixing everything, we structure the multilingual training carefully, and we explore different strategies, just like a zero sort, supervised fine tuning, many to many, source mix, target mix, and source mix. What exactly did we mixes the related source languages while keeping the target fix. So now see the if you see this diagram for our proposed source mix methods. So for example, if we have to go translate from a higher source languages such as English to any N1 extremely lower source languages, then what we did, in the source side we also introduce related source languages such as N2, N3 and so on. And in this case we are not giving any special signal to the encoder like what is your source languages, but during the target decoder we will give a language signal that you have to translate into fix ELRLs. And similar with the in the reverse direction, if we have to go from any ELRLs to high resource languages or medium resource languages, then again we will not give any signal to the encoder, but we will give language signal to the target decoders. We also tried it with like a target mix also. In the target mix we have a n number of extremely low resource from a high resource languages or a medium resource languages. In this in this setting we have not specialized the decoder to focus on any specific languages, because we have a n number of low resource languages, and we observe that in the target mix the performance is very poor as compared to the source mix. We also tried with giving the decoder to the target language stack, even if it performs very poorly. And in this works we also introduce a new machine translation corpus for Angika, which is a extremely low resource languages, comes from Indo-Aryan family and especially spoken in India and some part of Nepal, and it is written in Devanagari script and follow the same word order as Hindi. It has a significant speaker base, but it does not have any machine translation resources, and we publicly release this empty dataset for the Angika. You can use our data is available on Hugging Face dataset. In this experiment we selected an LLB seed corpus, which is a low resource machine translation corpus released by Facebook. It has 6,000 training samples, and we evaluated on floors 200, which has 1,012 samples. And we selected 14 different ELRLs, 4 from the African group, Nigerian Furfule, Noir Bambara and Tamask, 4 from the Romance group, Frulin, Lingurian, Limburgis and Sardinian, 3 from Indic, Angika, Bhojpuri and Maghreb, and 3 from the Arabic group, Dari, Kashmiri Arab and the Southern Pashto. We experimented with LLMs, decoder only LLMs such as Llama 3.1 and Gemma 7b, and we see that like there's decoder only have a very poor performance, and the encoder decoder LLM such as Aya has a very good performance. So we continue with Aya 101, and we also want to check how the performance of neural machine translation model on this extremely low source languages. So we use MT5 large model for that. And keeping in mind, we have not fully fine-tuned the Aya 13 billion. We apply the LoRa. Now coming to the result, if you see the result across all 14 languages, this graphs only shows the average performance. All these detailed experiment results are available on paper. You can find it out. So if you compare it with our proposed source mix methods compared to naive multilingual many-to-many translation, it has a around 11-point improvement, and compared to supervised fine-tuning, we shows a strong initial result. We see a performance jump of 6 blue points and 4 points in the CHRF++, and we see a similar performance boost in when we translating from MRL to ELRLs. We choose the Hindi as a MRLs. So here, if you see, the M2M and source mix have a similar CHRF values. Is it only because the source and target have a similar script, and CHRF is more inclined to character with similarity scores? So we see a kind of similar CHRF. But when we go to the higher anagram match, the performance of source mix is much higher than the M2M. Now questions arise like why does source mix works? So it works because multilinguality helps, but it's not that any naive multilinguality will help. You have to take care of the related languages who shares the morphology and syntax, have a shared script, and decoder learns from multiple related languages while we keep the target fixed. And coming to the concluding part, the linguistic relatedness enables the positive transfer. Mixing related source languages yield the consistent gain. We in the evaluation study, we also have a vast number of experiments by changing the source languages from different family to different script, and we found that within the same language group and having the same script is much perform much good compared to intra-family relation. And also the directionality matters, like in which how you mix the languages, because the source mix consistently outperform the target mix. Yeah, that's all. You can find the code, paper, and the dataset here. And if you like to connect with us, you can follow me on X, LinkedIn, or GitHub. This is my handle for all across all social media. Yeah, thank you.